Basic curves in polar coordinates. As we see the polar equation in the form of the theta equals a constant number, where r is greater than or equals 0. So this equation doesn't depend on r. So the graph we're going to get as the graph of the ray with the angle theta equals theta 0. For the equation r equals a, this time regardless of the theta or an angle, we're going to get the circle with the radius absolute value to a and the center at 0, 0. In the case that r equals 2 times a times sine theta, we will get the circle with the radius absolute value to a and the center at the 0, a. And the 0, a is the point on the y-axis. Another case for r equals 2a times cosine theta. A circle, we're going to get a circle with the radius absolute value to a and the center at a comma 0. The circle with the center at a comma 0, which is the point on the x-axis. Note that as a 0a the center for r equals to a times sine, the 0a is along the y-axis. Recall the relationship of the y and the psi. Psi is the y over r, so that could be the something that you can see the connection. The point on the y-axis related to the sine function. The point or the center at the x-axis related to the cosine function. For these examples, we are going to convert polar equation to Cartesian coordinates and describe the corresponding graph. In part A, we have r times sine theta equals -3. Recall the relationship of the polar and the Cartesian coordinates. The r squared is x squared plus y squared, and an angle theta is the inverse tangent of y over x. And also another way, the x is r multiplied by cosine theta. The y is the r times sine theta. We're going to see which one is appropriate to use in converting from the polar equation to the Cartesian coordinates equation. For part A, r times sine theta equals -3. We can see that r times sine theta is equivalent to the y. So we just replace r sine theta with the y equals -3. Now the equation that we obtain has nothing to do with the r and theta. And this is the Cartesian equation for this problem. So then the graph we're gonna get the horizontal line. Next one, we have r equals 1 over sine theta minus 2 times cosine theta. Rewrite the equation by multiplying both sides by the denominator sine theta minus 2 times cosine theta to get r times sine theta minus 2 times r cosine theta equals 1. With the relationship that r sine theta equals y and r times cosine theta equals x, then we can get the equation in Cartesian system as y minus 2x equals 1 or y equals 2x plus 1 as the equation. And this one we're going to get the line with the slope m equals 2 and the y-intercept at the order pair 1, 0. For part C, we have r equals 5 times cosine theta. We're going to convert into the equation of the Cartesian coordinate system, or in the form of the x and y. We call x equals r times cosine theta, and y equals r times sine theta. And the x squared plus y squared equals r squared. We have r equals 5 times cosine theta, but we're supposed to get the r multiplied by cosine theta to get the full form of the x, or we can replace with the x value. So in this case, we have to adjust it a little bit by multiplying both sides with the number, with the value r, to get r squared equals 5 times r times cosine theta. Now we can see r times cosine theta can be replaced with the x value And the r squared is x squared plus y squared. And this is the square of the x plus square of the y, which potentially is a circle equation. We're going to adjust the form a little bit to make a clear form of the circle to see the property of it. So subtract 5 both sides, subtract by 5x both sides, get minus 5x, and then leave some room to adjust the form equals 0. To add the third term to obtain the perfect square, since the second term is negative 5, so a half of negative 5 is negative 5 over 2. We're going to add by the quantity negative 5 over 2 squared. If you add, you're going to add both sides of the equation to make it equivalent. And negative 5 over 2 squared, that is 25 over 4. So the three terms on the left-hand side here will form a perfect square as x minus 5 over 2 squared plus y squared can be rewritten as y minus 0 squared. Now we can see the equation of the circle with the center at 5 over 2, 0, and the radius, which is the square root of 25 over 4, which is 5 over 2. The next part, r equals 6 times cosine theta plus 8 times sine theta. We would do the similar technique, multiply both sides by the r to get r squared equals 6 times r times cosine theta plus 8 times r times sine theta. And then r times cosine theta is the x, r times sine is the y. We have the left-hand side at x squared plus y squared. So x squared plus y squared equals 6x plus 8y. That's similar situation as the previous problem. We are going to work on completing square for x and y. So rewrite it as x squared minus 6x plus y squared minus 8y equals 0. And then find the appropriate term to make it a perfect square. For the x, negative 6 divided by 2, which is negative 3. We're going to add over here by negative 3 squared. If you add on the left, you're going to add the same quantity to the right side. And then same way for the y to make it a perfect square. Divide negative 8 by 2 to get negative 4. So then we're going to add over here by negative 4 squared. If you add on the left, you do the same on the right hand side. Now we get the perfect square for the x as x minus 3 squared, perfect square for the y as y minus 4 squared, and the number on the right hand side, which is 9 plus 16, or it turns out to be 25, or write it as 5 squared. And then we can see the standard form of the circle. So this one will give you the graph, the circle with the center at 3, comma 4, and the radius r equals 5. Another example, r equals cosecant theta times e to the power 3 times r theta. It looks like r times cosine theta already ready to be replaced with the x value, but the cosecant, recall the cosecant is 1 over sine function. So we write it as r equals 1 over sine theta times e to the 3 times r times cosine theta. And then multiply both sides by sine theta. We can see the left-hand side as r multiplied by sine theta equals e to the power 3 times r times cosine theta. And then we can replace the r times sine theta with the y, r times cosine as a x. Then we obtain the equation y equals e to the power 3x. This time we have the exponential graph y equals e to the power 3x. Next part, we are going to convert the equation in the Cartesian system into the polar coordinate equation. We call x is r times cosine theta, y is r times sine theta, and the x squared plus y squared is r squared. Let's set them aside so we can use them as appropriate. Part A, x equals 16 times y squared. So x will be replaced with the r times cosine theta equals 16. The y is r times sine theta, and then we square it. Now we have r times cosine theta equals 16 times r squared times sine theta. Reduce the r both sides since r will be greater than 0, so we can divide all by r. Now we get the cosine theta equals 16 times r times sine theta. Solve for r because the function in polar coordinate would be in the form of the r and theta. And we can see r as a function of the theta. So the r equals the cosine theta divided by 16 times sine theta. Or we can write it as 1 over 16 multiplied by the cotangent theta. For part B, we have x squared over 9 plus y squared over 4 equals 1. This is the equation of the ellipse with the center at 0, 0. From x equals r times cosine theta, we're going to replace it over for the first term of the numerator. So r times cosine theta, quantity squared, divided by 9, plus for the y, replace with the r times sine theta, squared divided by 4 equals 1. And then simplify to by multiplying by the denominator, clear up the denominator. So multiply both sides by 36 to get 4 times r squared cosine square theta plus 9 times r squared sine square theta equals 36. And factor out the r squared. We have r squared multiplied by 4 times cosine square theta plus 9 sine square theta equals 36. Solve for r or r squared. So r squared equals 36 divided by 4 times cosine square theta plus 9 times sine square theta. Another example, x squared minus y squared over 2 equals 1. This is the graph. This will give you the graph of the hyperbola. X will be replaced with the r times cosine theta. And then we raise to the power second. Similar to the y, is 1/2 multiplied by r times sine theta squared equals 1. For our convenience, multiply all terms by 2 to get 2 times r squared cosine squared theta minus r squared times sine squared theta equals 2. Factor the r squared out to get r squared multiplied by 2 times cosine squared theta minus sine squared theta equals 2. And then solve for r squared. R squared equals 2 divided by 2 times cosine squared theta minus sine squared theta as the equation in the polar coordinate system.